Good afternoon, everybody. My name is Sinead Quinn-Phillips, and on behalf of the Water and Environmental Engineering Society, I would like to welcome you to today's webinar. We are delighted to have Lorraine Gaston with us today to give us an overview of Irish Water's interim pesticide strategy. Lorraine is a catchment scientist with Irish Water who is leading on the development of their drinking water source protection approach and managing Irish Water's activities in the Interim Source to Tap project and their new pilot source protection project. She has over 15 years experience working in the water and environmental sector. So I'll hand you now over to Lorraine. Thank you.
Hi, thanks very much, Sinead. So I'm going to be talking to you today about our Irish Water's risk management framework for pesticides in drinking water, which we published in our interim pesticide strategy this year. So I'll first start with a background of the problem we have with pesticides in drinking water, give you a bit of an overview of the policy context, and then we'll go into the details of what's in the pesticide strategy, covering the scope and the aim, the pillars of the strategy, and evaluation and review. And I'll then provide some examples of the progress we've made to date, and then wrap up with a summary. Every day, Irish Water provides 1.7 billion litres of treated drinking water to 918 treatment plants to over 80% of Ireland's population. We abstract water for supply from approximately 291 surface water catchments and 962 groundwater catchments. Our surface water sources provide 83% of our total supply by volume, and groundwater sources provide the remaining 17%. When combined, these catchment areas cover approximately 50% of the land area of Ireland, as you can see on the graphic just there on the right. So pesticides is a broad term used to cover different pest control agents, including herbicides, fungicides, insecticides, and rodenticides. And pesticides are commonly used across many sectors, including agriculture, forestry, horticulture, transportation, amenity industry, and even domestic use in gardens. And there are many sources or routes for pesticides to get into water sources, including surface water runoff from the land and accidental spills. And these risks change excuse me, with seasonality, weather patterns, crop rotations, and behaviours on the usage. And the main issue for us is that conventional treatment plants conventional treatment processes are not designed to remove pesticides. And it really doesn't take a large quantity of pesticide to exceed the maximum allowable concentration in drinking water. A single drop of herbicide can breach the drinking water limit in a small stream for up to 30 kilometres. Or another way of looking at it is one drop of pesticides in an Olympic-sized swimming pool is enough to breach the standard. So the standards for pesticides comes from the EU Drinking Water Directive, and it's 0.1 micrograms per litre for individual pesticides and 0.5 micrograms for total pesticides. And it's important to note that these standards are not health-based standards, but rather they reflect the limits of detection that the laboratories can get to. The World Health Organization do have health-based guideline values for pesticides, and the concentrations of pesticides that we find in drinking water are at concentrations that are well below these guideline values. For example, a particular pesticide called MCPA, which we commonly detect, has a lifetime guideline value prescribed by the WHO of 700 micrograms per litre. This is 7,000 times higher than the current regulatory limit of 0.1 micrograms per litre. So how do we determine what's a persistent failure when it comes to pesticides? So we're using a classification system developed by the EPA, who are our regulator. And we have two classifications, the WATCH and the ACT. The WATCH supplies are ones where there's been a failure of pesticides 1 to 3 times within a spraying season, which is April to November. And the action list is anything greater than 4 failures. And we only count 1 failure within a given calendar month, so we don't double count that way. So if something does get an exceedance of pesticide standard, it means that we increase our monitoring of that particular supply. And if it comes onto the action list, we work with stakeholders towards returning that supply back to compliance. So this slide is to give you an idea of the current status. So we have 38 supplies on the watch list. So that's 38 supplies with 1 or more exceedance, and 6 supplies on the action list. So that's 6 supplies with greater than 4. And this is a map just displaying where these catchments lie across the country. The kind of darker red are the action supplies. So in the middle, we have Longford Central and Belturbet, which are quite large catchments combined. Then Newport in County Mayo to the west. We've got Clonroach down in Wexford, which is a bit too small to show up on the map. But that's our only groundwater supply that's on the action list. And then down in the southeast, we've got 2 supplies which both abstract from the River Deal. Sorry. So the types of pesticides that we're seeing in drinking water are all herbicides. MCPA is the most commonly found one that accounts for greater than 50% of our exceedances. And that's then followed by glyphosate, 2,4-D, triclopyr and fluroxypyr. So I'll just tell you a little bit more about MCPA. It's a selective herbicide specifically designed to kill weeds without harming the crops beneath them. So they're commonly used to treat rushes. MCPA is highly soluble. It's got a low affinity towards organic sediments, and it can remain in the soil residually for 3 to 4 months. So that means that it's highly likely to run off the land, and it especially on poorly drained soils, and it will hang around a long time. It also has a persistence of 2 to 5 weeks in water. So Irish Water are part of the National Pesticides and Drinking Water Action Group, which was formed in 2015. It's currently chaired by the Department of Agriculture, Food and Marine. And it was established to provide a coordinated and collaborative approach to prevent the ongoing prevalence of pesticides in drinking water. You can see the list of current members there on the right-hand side of the screen, and it includes organisations such as EPA, National Federation of Group Water Schemes, Teagasc, local authorities, and the Local Authorities Borders Programme, or LORPRO. The key objectives of the group are to enhance collaboration between key stakeholders, provide communications regarding pesticides, exceedances in drinking water, raise awareness at a national and a regional level, promote best practice of pesticide use and storage, identify policy and implementation gaps, and support catchment focus groups. And these are groups that are set up for drinking water supplies with more persistent exceedances to try and tackle the issues more locally. Next, I'm going to cover the policy context for pesticides in drinking water. There are 3 key pieces of legislation that govern pesticides in drinking water. There's the Sustainable Use of Pesticides Directive, which kind of does what it says on the tin. It looks at reducing the risks and the impacts of pesticide use on human health and the environment, and it promotes the use of integrated pest management. Then there's the Drinking Water Directive, which provides the standards that the drinking water must meet. And we have the Water Framework Directive as well. And it has objectives for bodies of water reaching good status. There's also a specific article 7 within the Water Framework Directive, which says we must ensure that necessary protection of water bodies to reduce the level of purification treatment required in the production of drinking water. There are also 2 recent strategies that have been published by the Commission as part of the European Green Deal. It's the Farm to Fork strategy and the EU Biodiversity strategy. And within these, the Commission has committed to taking actions to reduce the use and risk of chemical pesticides by 50% by 2030. Now bringing it down to the national level, there's the River Basin Management Plan, which is required under the Water Framework Directive, and it establishes the catchment-based approach to protect and improve waters. It requires that objectives for designated protected areas must be met, and these include the drinking water protected areas. Then there's the National Pesticides Action Plan, which is developed under the Sustainable Use of Pesticides Directive. And it lists out actions to protect drinking water quality. And this includes buffer zones to safeguard the use, drift reducing spray nozzles, training on best practice measures, the establishment of the drinking water the National Pesticides and Drinking Water Action Group. That's always a mouthful, that one. And a focus on priority catchment areas to target actions. And lastly, the HSE and the EPA published a joint position paper on pesticides in drinking water back in 2019. And it highlights that prevention of pesticides from entering drinking water sources should be a priority and carried out by multiple agencies. There's also an acknowledgement that treatment should only be considered when all efforts to prevent contamination of the source has failed. In 2015, we published our Water Services Strategic Plan, which sets out our objectives for the delivery of water services up until 2040. And it contains our strategic objectives in relation to drinking water source protection, which comes under the objectives to ensure a safe and reliable water supply, which advocates the source to tap approach, and also to protect and enhance the environment. So we will deliver our services in a sustainable manner and work with stakeholders to support a catchment-based approach. We've adopted the Drinking Water Safety Plan approach, which is recommended by the World Health Organization. It seeks to protect human health, to identify, assess, and manage risks to water quality and quantity. It takes the holistic approach from source through to tap. And this approach is also central to the new Drinking Water Directive that will come into play in 2023. And now we'll just go into the interim pesticide strategy itself. So I guess the question is, if we have all of this legislation and policy, and we do have good working relationships with our stakeholders, why is there a need for a strategy? Well, ultimately, Irish Water is responsible for providing clean and safe drinking water, excuse me, and pesticides are a regulated parameter. And we wanted to be able to provide a strategic approach to addressing pesticide risk within our drinking water within our drinking water catchments. And in doing this, address regulators' concerns that we do have a strategy for pesticides. It provides a transparent framework for all catchment management activities that stakeholders are currently undertaking, and helps to embed the catchment management approach within Irish Water. And you might have noticed that we've been calling it an interim pesticide strategy, and that's because it's intended to cover quite a short period of time, really from 2021 to 2022. And that's because during this period, national source protection legislation and policy will be revised. We have ongoing pilot source protection projects that we need to gain learnings from. Drinking water safety plan methodologies are being established, and we're still building collaborative working relationships. So this interim strategy will be replaced by a more holistic strategy for source protection, which covers other source risks and contaminants. The scope of the strategy is to provide a risk management framework to objectively understand and manage pesticide risk on a prioritised basis within drinking water catchments for public water supplies. The overarching aim is to protect drinking water sources from pesticide contamination and improve the quality of sources in order to safeguard human health and the aquatic environment. We propose to achieve the same primarily through working in collaboration with all the relevant stakeholders who share the common goal of reducing the risk of pesticide contamination of our drinking water sources. So the strategy can be used and applied by the stakeholders of the National Pesticide and Drinking Water Action Group, but it's not intended to define or steer any external organisations' needs or particular objectives. So this is what is contained within the strategy. This is our risk management framework for pesticides. It contains 3 key pillars: collaboration, understanding risk, and managing risk. And collaboration occurs during all the stages of the risk management process. And this framework is in line with ISO 31000 for risk management. So this slide just shows the framework in a little bit more detail. So you've got pillar 1, collaboration with key stakeholders there on the left. At the top, we have pillar 2, about understanding risk and the sub-elements within that. And then pillar 3, managing risk and its sub-elements. And I'm just going to talk you through each of these in turn now and provide some examples. So our collaborative actions under pillar 1 include our work with the National Pesticides and Drinking Water Action Group and its catchment focus groups. It also covers the pesticide updates we provide to our stakeholders and our approach for responding to pesticide exceedances and how we communicate those with stakeholders. So I'm just going to take a sip of water. Next is pillar 2, which covers the risk assessment actions. So first off, it's the catchment characterization and risk assessment portion. And we start off by delineating the catchment boundaries for our abstraction catchments. And then carry out drinking water safety plan source risk assessments following a source pathway receptor approach. And in some instances, further catchment characterization may be required to build the conceptual understanding of a particular catchment. Pesticide monitoring is also covered underneath this pillar, and that includes drinking water compliance monitoring that we undertake, but also collaborative catchment monitoring undertaken by key stakeholders such as the Animal, Plant and Health Association. And under this pillar as well, we've made a commitment to support pesticide research, particularly in areas of pesticide risk mapping and trying to understand sources and pathways. This slide presents an overview of our drinking water safety plan source risk assessment approach. A much greater emphasis is being placed on this, and historically, drinking water safety plan source risk assessments would have largely been subjective and relied on professional judgment. And we are currently developing semi-quantitative methodologies using GIS to identify, assess and prioritise risks. We are also carrying out site-specific source and sanitary surveys, which will feed into the overall risk assessment results. Now, as an example, we're looking to develop an MCPA risk map using usage data that we've obtained from the Department of Agriculture's website. And it's split into 3 regions. That's currently the best resolution we can get at the moment, but it does show that the greatest usage is in the northwest of Ireland. And then we can then overlay the usage map with areas where we expect the usage would be higher. So taking the land cover map and extracting all the agricultural area. And also looking at the soils map. So we expect that MCPA is more likely to be used on wet soils in agricultural areas. And finally, we're going to go through the pillar 3 about managing risk. And essentially, catchment management will be our primary approach for managing pesticide risk. And we will also have a role in trying to influence policy, manage future risk as well, and are developing an approach for investigating alternative options to minimise pesticide risk when catchment management or enforcement measures have proven not to be sufficient. So catchment management is quite a broad term, and it includes things like raising awareness, provision of training and advice services, and also pilot scale projects of trialling interventions. And we're working with various partners to do this. Catchment management has added benefits as well, such as improving local biodiversity and general water quality parameters under the Water Framework Directive. There's also potential for climate change mitigation by limiting the energy requirements that additional treatment might require, and potential for climate change adaptation within the catchments by making water quality more resilient in the long term. The National Pesticides and Action Group have been working together to raise awareness of the issue of pesticides in drinking water. And we do try and keep our messages positive and highlight the additional benefits to biodiversity as well. And some of the ways we do this includes proactive media engagement, including radio, print, and online. We use targeted social media posts, and we work together to develop guides and videos and disseminated those. We also do things like target specific online advertising platforms such as Done Deal, and use that as a platform. And we support community initiatives such as the Let It Be campaign, which is being run by the National Federation of Group Water Schemes. And we work very closely with the Agricultural Sustainability Support and Advice Programme, also known as ASAP. And they're a free and confidential farm advisory service to help improve water quality. And they partner with DAFM, DHLGH, Lough and Dairy Sustainability Ireland. You can see on the slide there just some examples of the types of measures they've recommended to farmers in order to protect water sources from pesticides. The map on the right shows the priority areas that ASAP are focusing their work on. We're involved in pilot source protection projects to trial catchment scale interventions to reduce the risk of pesticides causing exceedances in water supplies. The first example is the Source to Tap project, which is a cross-border partnership project that focuses on the River Erne and River Derg, which are cross-border catchments. It's an Interim funded project that's match funded by the departments either side of the border. And we're a partner in this project with Northern Ireland Water as the project lead. It began back in 2018 and it will continue into next year. It aims to develop sustainable catchment scale solutions for the protection of drinking water sources with a particular focus on MCPA, sediment loss and colour. Also under the River Basin Management Plan for Ireland, we've made a commitment to coordinate our own pilot source protection project on one of the actor watch list supplies. And we'll deliver this project at a local level in collaboration with key stakeholders. So we've just started the project this year and we're still in a bit of a ramp up phase. But the main aim of the project is to trial innovative monitoring and management strategies aimed at reducing the risk of pesticide contamination of drinking waters. The National Pesticides and Drinking Water Action Group have a role in influencing policy to help ensure that it supports the protection of drinking water sources from pesticide contamination. And this includes things like the identification of drinking water protected areas and areas for action under the River Basin Management Plan, identification of safeguard zones under the Water Framework Directive and the SUDS Directive for high risk drinking water catchments. And we're also active members of relevant national and European groups and respond to consultations to ensure that drinking water quality can be improved and protected. Oh, slide's gone a bit glitchy. So in some instances, we might find that collaborative catchment management approach or enforcement action by DAFM may not be sufficient to reduce the risk of pesticides. And in this instance, we may have to investigate alternative options for reducing the risk. And these options include things like blending abstraction management schemes, looking for alternative sources or even relocation of abstraction points, and the treatment of pesticide using additional processes such as granular activated carbon. And we'll also be looking to incorporate all of this into our decision-making processes so that we can reduce the risk to new drinking water sources from pesticides. And this will be part of the National Water Resources Plan, which is currently underway. Monitoring and evaluation are going to be key to assessing whether catchment management-based approach is going to be effective. And a catchment management-based approach is not a short-term solution. On average, it can take 4 to 10 years of post-intervention monitoring data to demonstrate that a change has occurred. And we also need to consider external factors which can cause substantial challenges to understanding how actions on the ground translate into improved drinking water outcomes. These external factors include things like land use change, pesticide use, which varies seasonally, river flow and groundwater recharge levels, and weather patterns from year to year. So we've adopted a weight of evidence-based approach, and this is following on from some work done by catchment sensitive farming in the UK. And we'll be adopting a variety of indicators to do this. So rather than just looking at drinking water quality compliance, we're going to be monitoring the inputs to the process, including our national and catchment partnerships, the evidence base that we're building in terms of the monitoring and characterization studies. We're also tracking the activities on the ground, so trying to quantify the level of engagement in terms of our catchment management actions. And then we have a variety of indicators that we'll be looking to use to monitor the drinking water outcomes as well. So I'm going to just go through a couple of case studies now, just to show you what this looks like in practice. So the first case study is around our Kilkenny city Troyswood supply, which abstracts from the River Nore. In 2017, we noticed persistent exceedances of the drinking water standard for MCPA. And actions undertaken by the National Pesticides and Drinking Water Action Group included developing best practice information, such as guideline booklets and videos, which were disseminated. We also undertook catchment monitoring program, which is run by the Animal, Plant and Health Association. And it was able to highlight a hotspot of MCPA levels in the catchment. So this is just a little snippet of the catchment here overlaid on a soil drainage map to the north, I guess the top right of your screen, that's probably the easier way to say it, is kind of a muddy green area. That's the poorly drained soil. So that's kind of where you would expect more MCPA usage. And that's indeed where we found it when we did the monitoring. So we were then able to use this information to raise awareness of the issue at a local level through the media, but also by direct engagement with the landowners. So there's been significant reductions in the MCPA levels detected within the Nore and its tributaries, and drinking water samples have been compliant since 2018. We will continue engagement at a local level to help ensure that this positive change can be sustained over time. The second example is not quite so straightforward. It's our Longford Central supply, which is currently still on the Act list. It abstracts from Lough Forbes. We've noticed persistent exceedances of MCPA since 2017. Lough Forbes is quite a large catchment, and understanding the sources and the pathways of MCPA to the lake has been quite challenging. We do know that 86% of the inflow to the lake is from the Upper Shannon, which is the large green area on the catchment map there. So actions undertaken by the National Pesticides and Drinking Water Action Group included the establishment of a local catchment focus group, which is chaired by Lough. raising awareness of the issue at the regional and local level through media and direct engagement with landowners, best practice dissemination, and also to help understand the pesticide risk. A collaborative catchment sampling campaign was undertaken in 2020, and agencies involved included EPA, Longford County Council, Interim County Council, the Animal Plant and Health Association, and Irish Water. And we used the data to help determine where the higher risk areas within the catchment might be. And for this particular complex catchment, it was important to have flow data as well as quality data so we could estimate loads and where they were coming from. So don't worry too much about the detail on this graph, but it's really just to show that you can see the intake concentrations of MCPA in the light blue. And some of the time you can see it correlates with the levels in the Upper Shannon. And then sometimes we get some spikes in the intake, and it doesn't necessarily correlate to what's happening in the Upper Shannon, and it might be more closely linked to what's going on in the River Rin. So we've used this information and some of the other analysis to try and target where ASSEP can provide further advice to landowners within the catchment. So that's kind of where we are now with Lough Forbes. That work is still ongoing. And then this just presents a more national picture. So this graph shows the proportion of samples that exceed the drinking water limit of 0.1 micrograms per litre. And what we've done is taken 2016 and 2017 as our baseline years, because we were still really in a ramp up phase of the national group at that stage. So if we take those as baseline years, we can see that the past 3 years, there's been 44% lower percentage exceedances compared to the baseline year. And that varies from year to year as well. In addition to that, we're also seeing a large drop in the maximum concentrations that have been detected, and the annual average of the exceedances as well has also dropped when compared to the baseline period. And we'd like to think that this overall improvement can be attributed to the collaborative actions of the National Pesticide and Drinking Water Action Group to date. So just to summarise, I've just got one slide of a summary. I'd just like to bring it back to our 3 key pillars for managing pesticide risk. Collaboration is really the key to successful source protection, especially for us as our catchments cover over 50% of the land area. So it really needs the help of others. It's really important to understand the risk before we try and manage it. And we've seen that from some of the case study examples as well. And lastly, it's more than it's about more than pesticides in drinking water. There really are added benefits to this approach, such as benefits to biodiversity, general water quality improvements, and climate change. If you're interested in finding out more, our interim pesticide strategy is published on our website at this link. And you can also find further resources at our partner websites, Teagasc and Daffin, if you're interested in, excuse me, any of the guidelines. So thank you for your time.